Hello Matrix and welcome again. Today we are continuing on with our accepted reasons for your Matric Maths paper 2 and this is coming up in the geometry section. So what I want to do is look at your angle at center equals 2 times angle at circumference, because this can come in 3 different forms. Now the first one is the one that most of you are familiar with and find quite easy, but then it's a little bit trickier to spot when it's in a different form. So I want to just start with the basic one. Now, if you're looking for the proof of this, I'm going to put a link in the video below right now. So check that out if you're looking for the proof. Okay, so let's look at what we've got is the center of the circle and the radii going to A and B. And then let's make this C. So what we've got is this common chord AB, and then going to making an angle at the center and then making an angle at the circumference. So what the proof says is angle at center equals 2 times angle at circumference. So what they mean is this angle here, 2x, is double x, the angle at circumference. And so if you were given this, you could therefore say that AOB equals 2 times ACB. And there the reason is angle at center equals 2 times angle at circumference. Okay, so that is the most common form that you'll see of this, where you've got this sort of arrow shape. Now, if you can actually move this C anywhere along the circle and you can still use this. So let's say that I moved C to here. We'll do it in green. Well, this is another way of seeing it. So you've got, again, the angle at center. So this now still 2x, and this little one x, this ACB. And so you'd say exactly the same thing. AOB equals 2 times ACB. And the same reason, angle at center equals 2 times angle at circumference. So this one is fair, you've just got to be able to spot it. And often these geometry questions, there's a lot of lines everywhere. So you just need to be looking for this. It looks like the bow tie, but it's not a bow tie like from each side of the circumference. So it's not like angle in the same segment where they're both at the all 4 points of the circumference. Here we've got the bow tie within this kind of semicircle. Okay, now the third one is a little bit more tricky. So let's say that we moved the C here. So we moved it all the way around to here. Okay, so what I want to do is just examine this a little bit. Let's say that this, we'll put it in, I'm going to put this in a sort of a light greeny color, just to sort of look at the examination quickly of what's happening. Okay, so let's say that, okay, so all of the thing we're going to put in pink because, okay, so let's say that this is 2x, which, as we've done before, well, we can see that this is 2x here. This is x here. So, and that's from this one, from the first thing. So we know that this, because of angles in a cyclic quad, this is actually 180 minus x. Okay, so it's this angle here is not the angle that's, so the angle at center, this one is not going to be 2 times the angle at circumference, like over here. If we're examining this angle 2x, we actually need to look at the one on the other side. So if this is an angle in a revolution, so in other words, this is 360 degrees, we see that this is going to be, and I'm going to remove the O just so that you can see it better. We know that it's the center of the circle. This is going to be 360 minus 2x. And so do you see that this is 360 minus 2x, and this is 180 minus 2x. And so this ACB is half of the larger angle, we call the reflex angle, because it's bigger than 180. So for this one, what we're actually looking at is this angle here, ACB, and the reflex angle. So when you're drawn this, so I'm going to now remove the things that don't matter because we finished our examination. So I'm going to take away the green bit because that was just using this to explain why it's slightly different when we look at the when C moves in between A and B. So what we're actually looking at is there. So it's the reflex angle we can see is, and our reason is going to be the same thing. So our reflex angle is twice the angle at circumference, but we're looking at the one on this side, not on the outside. So we can now say, we're still going to say that AOB equals 2 times ACB, angle at center equals 2 times angle at circumference. But we just need to remember which one we're talking about, which angle. We're talking about this angle and this angle. Okay, so hopefully you can see the difference between that third one in pink. They're all the same theorem, but it's just slightly different angles that we're looking at, particularly on that third one. So hopefully that made sense. If it didn't, you can always watch it again and just digest it. And yeah, hopefully that helped, and I will see you next time for another video. But if it did help you, find the subscribe button down below and click it and like and share with all your friends and all that good stuff. And I will see you in the next lesson.